Good morning. And also like to bid everyone a happy Easter. It's kind of a shame, really kind of sad, that so many only think about the resurrected Christ once a year. We're told in the New Testament that we are to observe the Lord's death every week, every first day of the week. And we do that in partaking of the communion. And it's very hard not to remember his death and also to think about everything else to do with his life as well. Even his birth can come to mind, but especially his resurrection would come to mind when we think about his death. And the fact that Jesus was resurrected is a fact. It just is. It's provable from evidence. If the enemies of Christ could have proven that he did not rise from the dead, they would have done that. And they would have made proof of that, but they could not. But that's one thing that scientists cannot go back and look at. They cannot go back and look at that and observe it in the way that science does. And we're going to talk about that today, what science does. So science is limited in what it can do. Science makes observations. Dr. Douglas Marsland has well said, the primary basis of all scientific thinking is observation. And Dr. Paul Weitz, in his book, Elements of Biology, has noted, all science begins with observation, the first step of the scientific method. At once, this delimits the scientific domain. Something that cannot be observed cannot be investigated by science. This is from a scientist. Dr. Henry Morris has also stated that science thus involves facts which are observed and laws which have been demonstrated. So they have to be able to observe it. And there are certain things that science just cannot go back and observe. They can't really tell us a whole lot about the beginning of the earth. Sure, there are some things that can be known, but they can't go back and observe to see what happens. And so all they can do is make theories about those kind of things. On the other hand, the Bible gives us facts about what happened and what took place. And so people just have to make a decision when it comes to things like that. Are you going to believe that there's a God that's always been? Or are you going to believe that there's a little speck that, boom, created the universe that's always existed? Something has to have always been here, because you can't get something from nothing. But observation. Secondly, in science, statements and definition of a problem has to be made. Scientific inquiry is characterized by what is called the hypothetical deductive model. And the scientist notes a problem based on his observations, and then he states the problem as he wishes to investigate it. He then gives his hypotheses and gathers facts either to substantiate what he thinks or to negate what he thinks. And that's the problem. Some people start off with what they think may happen and they don't want to change, so they try to manipulate the data to prove what they want. One thing that I think about that comes across rather blatantly was the experiment with moths and the change in their colors. And the scientists actually took dead moths and pinned them to a tree and other things like that to prove his point. And it was finally proven to be a hoax, but yet science teachers in high schools still teach it, even though it's a hoax and has been proven for years to have been a hoax. People need to look further into things than just that. But science, they come up with an idea. And that's the way we learn things. Come up with an idea and then experiment to see if what we think is true or not. But please, at least be honest about your work then, as you're trying to go about whether this hypothesis that you have is true or not. And honestly look at it to see if it is. And then thirdly, there is the formation of the hypotheses. Dr. F.J. Ayala says a hypothesis is empirical or scientific only if it can be tested by experience. A hypothesis or theory which cannot be, at least in principle, falsified by empirical observations and experiments does not belong in the realm of science. So he admits that you can prove it or you can falsify it. And if those two things aren't possible, then you're not really looking at hypotheses. Dr. David Hall, in his work, Philosophy of Biological Science, states, first and foremost, a scientific hypothesis must be testable. Ideally, the hypothesis to be tested is universal in form. And then you have to make deductions, conclusions. You have to draw a conclusion from your hypotheses or from your prediction. Professor John N. Moore writes, the heart of the scientific method is the problem hypothesis test process. And necessarily the scientific method involves predictions. And predictions, to be useful in scientific methodology, must be subject to test empirical. And Dr. Duane Gish agrees. He says, thus, for a theory to qualify as a scientific theory, it must be supported by events, processes, or properties which can be observed, and the theory must be useful in predicting the outcome of future natural phenomena or laboratory experiments. An additional limitation usually imposed is that the theory must be capable of falsification. That is, it must be possible to conceive of some experiment, the failure of which would disprove the theory. Dr. Paul White states, deductive logic is used extensively by scientists to obtain predictions from hypotheses. Most scientists are so accustomed to deductive reasoning that formal construction of if-then statements is unnecessary in setting up experiments. And then there is a man by the name of Keaton who reminds us, however, that induction is also a necessary part of the process. After the scientist has reasoned inductively from the specific to the general, that is, from specific factors to general statements, he must reverse his field and reason deductively from the general to the specific. And so this is what science does. They come up with an idea, they develop an idea, then they look at it, they draw conclusions, they make predictions, and then they have to test it. They have to look at it. And the way that they do this then is number 5, by experimentation. Dr. Moore observes, scientific activity involves the search for facts that can be observed or demonstrated, and for laws that have been demonstrated also by means of trustworthy methods of discovery. And at the core of scientific method or methods is experimental repeatability or reproducibility. Dr. Morris agrees. The scientific method involves experimental reproducibility with like causes producing like effects. You experiment, you do it, you see what happens. You do it again, you see if the same thing happens. You do it again and see if it happens. You see if there's changes, you see if it always happens the same way. And if things always happen the same way, then you can come up with a formation of other things, as we will talk about in just a few minutes. But you experiment, you see what happens and what takes place. And there's nothing wrong with that. Sometimes people look at science as though we ought to just stay away from it. It's something that's evil, and it's not. Science is not evil. It can be used for evil, but it's not evil in and of itself if used correctly. And again, more on that later as well. But next, number 6, is when you experiment, then you come up with a formation of a theory or a law. A theory is a broadly based, widely accepted hypothesis supported by at least some good experimental evidence, and it is considered an accepted answer to explain something unusual. A good theory meets certain criteria, which would involve, first of all, it identifies an orderly relationship of various and diverse observations. Secondly, it predicts a future outcome. Thirdly, it is modifiable. And fourth, it can be used to develop new direction for additional research. So as we've already seen, a theory must also be falsifiable. A scientific law, on the other hand, is viewed as reflecting actual regularities in nature. In other words, there are no known exceptions to scientific laws, else they would not be laws. That is, the law of biogenesis, the law of causality, the laws of thermodynamics. Nothing is totally destroyed. And you say, well, I can take a piece of wood and set it on fire and that's destroyed. No, it's not. No, it's not a piece of wood anymore. It's smoke and ash and other things, but all that it took to make that log, all the molecules and all the things that were in that log are still here, just in another form. That's a law. And other things that go along with the thermodynamic laws, which I don't have time to get into in this lesson. But just looking at those two laws can answer so many questions about the world and how that things always get older. Have you ever bought a car that got newer? You drove it and you drove it and you drove it and it just got newer and newer and it never needed to be fixed and nothing ever broke down on it. Well, if you got a Chevrolet, maybe. No. But they don't get newer. They get older. Everything, even a Chevrolet. It gets older, not newer. And so there's so many laws that are there that help to prove things. And science tells us about those. So science is good. True science goes right along with the Bible. Dr. George Gaylord Simpson, in speaking of science, has said, the important distinction between science and those other systemizations, the arts, philosophy, and theology, is that science is self-testing and self-correcting. The testing and correcting are done by means of observations that can be repeated with essentially the same results by normal persons, operating by the same methods and with the same approach. But after science has performed its duty, may it then pronounce absolute truth to the waiting world? The answer is no. Simpson explains, we speak in terms of acceptance, confidence, and probability, not proof. And right now, in these days and times and the things that we're going through, I wish more people would remember that. That science cannot do certain things. And we have to take everything that science says and put it along with the Bible. And if by proof, he goes on to say, is meant the establishment of eternal and absolute truth, open to no possible exception or modification, then proof has no place in the natural sciences. Alternatively, proof in a natural science such as biology must be defined as the attainment of a high degree of confidence. Dr. Bolton Davidheiser, quoting Simpson, says, the eminent George Gaylord Simpson says concerning the inductive nature of the scientific method, the concept of truth in science is thus quite special. It implies nothing eternal and absolute, but only a high degree of confidence after adequate self-testing and self-correcting. Professor Simpson further says that above the level of triviality, there is hardly any scientific subject on which agreement is literally universal. He says that the most fundamental reason for a disagreement in science is the inherent impossibility of complete certainty. He points out that one fact may disprove a theory, and not all facts can be observed. Therefore, an investigator cannot completely discard the possibility that a discrepant phenomenon may occur. He further points out that in any complex situation, the data are rarely so complete that only one explanation can conceivably be correct. In other words, there are likely to be rival theories. Science, then, as great as it is, does not provide all the answers. And that's the main thing I want to get across. It doesn't provide all the answers. Quote, there can be no real conflict between natural science and true religion because their spheres are entirely distinct and separate. Natural science deals with physical entities by abstraction, experiment, and mathematical measurement, while religion is an attitude of trust and love toward an infinite God, which results in a vital experience constituting the essence of religion. Conflicts between these two are always the result of misinterpretation and misrepresentation of one or the other or both, and history abounds with illustrations of all these forms of confusing contradictions. Science and religion, while thus separate, have various relationships which make each the servant of the other. Dean Inge remarks, we may hope for a time when the science of a religious man will be scientific and religion of a scientific man religious. True science and true religion are not in conflict. They are not. They are, in fact, wholly harmonious. Science is that looking glass given to man by God for the purpose of investigating and having dominion over all His creation. God gave us the ability to use our minds, to think about things, to experiment, to come up with hypotheses, and to do this, but not to go against Him. If it goes against God, then it's wrong. And true science does